Hi and welcome. My name is Rafael Taubinger. I'm Product Marketing Manager at IAR. I'm joined by Anders Lundgren, Product Manager at IAR for ARM Solutions. We are excited to walk you through the latest updates in IAR Embedded Workbench and IAR Build Tools. So the latest version is designed to enhance your development experience. Some of the highlights include some enhanced CMake support, MISRA C 2023, command line debugging with J-Link, and there is also Cortex-M55 and M85 trace capabilities, and lots of new devices as usual. So Anders will provide you an overview of all these features, and I will wrap it up with a quick demo to show these features in action. Let's dive in. Anders, the stage is all yours.
Thank you, Rafael. We have quite a lot of new features in this release. It covers the IDE, it covers the debugger, it covers the compiler, and then we have some more features as well. So we will go into detail now. CMake has become the de facto standard today for building projects, building applications. Today, CMake is the standard for projects running in CI/CD specifically and mainly. On the IDE side, the CMake support has been lacking, and we at IAR is trying to make your life easier. And what we try to do is to bridge the IDE world together with the CI/CD world. And one step in that direction is that the Embedded Workbench IDE now can import CMake files. So it will give you an overview of the real picture of the CMake content. So you can actually build your project from a CMake file. You don't need the IAR project file to match the CMake. You just deal with the CMake file directly. This enables you to debug the project as well in the C-SPI debugger. The way to set this up is that you configure EWARM to find CMake. And that's done in the IDE options, and you point to the CMake executable. Then you create a new project, and the project toolchain type here is CMake for ARM. And then you say that you want to import a CMake list.txt. And when you have done that, that's all you need to do. Then you have everything in place, and you get the content of the CMake list file is reflected in the IAR project manager view here. And when I say import, it means that you're basically in a read-only mode with respect to CMake. So the IDE mirrors the CMake list file, and you can edit files. You can you can start the debugger and so on, but you can't actually change the CMake list file from within the IDE. That is done directly on the CMake list file. Then we move to the compiler and the debugger side, a bit more on a new core that we have added. Is the ARM Cortex-M52 core. It's also called Star MC2 for the Chinese market. It's based on the ARM v8.1M architectures, and so it includes the Helium M profile vector extension and low overhead loops. Feature-wise, performance-wise, it fits between the Cortex-M33 and the M55. We do actually see some companies moving into this, so it's going to be interesting to have yet another M core support and for customers to make successful projects based on this core. We added debug capability in our command line tools to better support continuous integration, continuous deployment, test activities using the debugger. Before we supported iJet, our own debug driver. Now we have J-Link as well. If you want to use J-Link, you have to note that the driver itself from Segger is not included in the installation, so you have to get that from Segger and install it separately. We also have added a bit better mechanism to generate a sys-by-bat command line from the IDE. You can do that by yourself. It's well described in the manual, but it can be a bit tricky. It's a lot of options to tell the debugger on the details. So there is a shortcut here that allows the IDE to actually generate a Linux shell file, .sh, or a Windows batch file, a .bat, or a Windows PowerShell, a PS1. That will ease the work of setting up this command line to kind of directly move on to use the command line instead of the IDE for running sys-by-bat. We have done quite a lot of trace enhancements. The bulk of the effort has been to rewrite the trace decoder, and this is for improved performance and also improved stability. It goes across the line of protocols like ETM, ETB, ETF. As part of that, we also added the Cortex-M55 and M55 ETM trace. So you can now do full instruction trace on also the latest Cortex-M ARM cores. Next up is the ARM SDM debug authentication for iJet. This is a security feature. Many devices today provide cryptographic mechanisms to unlock and lock devices so that you can't debug unless you have the right keys and certificates in place. To avoid having separate implementations for every silicon vendor, ARM defined the ADAC standard as part of the platform security architecture. And that means that you get the secure debug manager from the silicon manufacturer, and then the debugger can use that debug manager, and the IDE in the debugger will then reflect the features available on the device. We started implemented this on the ST-Link in the previous release, but now it's also supported by iJet, our own debug probe. To use this feature, you have to get the SDM DLL from the silicon vendor that you're using. So you have to either contact us or contact the silicon vendor to get this feature up and running. We have a history of adding new GCC C language extensions, and that journey continues. In this release, we added quite a lot of new built-in functions. There is a new attribute named visibility. We also added arithmetic support for void and function pointers. The attribute packed is now allowed at the end of enum declarations. We support some additional GCC relaxations to the C standard, and void functions can now return void expressions, and we also allow mixing void star and function pointers in the same way as you are allowed to do in the GCC environment. CStat is our static analysis tool, and We are keeping up with the latest MISRA C standard updates. This time is MISRA C 2023. It incorporates the MISRA C 2012 amendments, plus the technical corrigendum number 2. And the latest update from us also incorporates support for the C11 and C18 language features. We have added shared objects libraries. This is basically the same mechanism as you used to on the desktop. If you are in a Windows desktop environment, you have DLLs. If you are running Linux, you have the .so files, the shared objects. And this is an implementation that is very close to the Linux shared objects implementation. So the linker can now generate not only a pre-built ELF file, it can also generate a shared object as output. That means you can have an application that is not fully static. During runtime, you can load a shared object that you have created by the linker. You can actually load multiple shared objects and switch between them. The loading is done via a function called DLOpen that is part of the dynamic loader. So there is actually, the dynamic loader is a little bit of a linker itself that you use at runtime. So how do you use this? Well, it's not that simple actually, but the mechanisms are there. You need to have access to a dynamic loader. Either you write it yourself or you get the functionality as part of an RTOS operating system supporting this mechanism. And this is something we expect to be more common in the future, that the real-time operating systems will support the dynamic loading mechanism. There is an example available, as you see in the last bullet here. So you can take a look at that example if you want to go further on this. SARIF is a way of standardizing the output format from command line tools like the compiler, like the static analysis tools, linker, diagnostic messages, etc. If you just use the bench in isolation, you won't see that much of a use for this. It's just another way of expressing how the error messages from the compiler, for example, look like. But if you take this in a broader context and you want to use it in a CI/CD system and you want to automatically parse it, or you want to make it visible in a more structured way, there is quite a lot of tools available on the net that can parse and present SARIF output messages. So we expect that more and more tools, both from us and from the embedded world in general, will start using this. It's a fairly popular diagnostic format message, and now we support that, and we will broaden our support for this in the future as well to make it more easy to visualize diagnostic messages from our tools. As usual, we have new devices, and this time it's quite a lot of them from different partners making devices. I won't mention them in this context, but you can take a look yourself and see if it matches your favorite device. The details are in the release notes, so if you want to get, for example, what are the specific devices from a certain silicon vendor, please refer to the release notes.
Great, so now it's my turn again. So I will change screens here and start to demonstrate all these new great features in action. So you should now see IAR Embedded Workbench in the screen. And let's explore the newest features in IAR Embedded Workbench. First, as mentioned by Anders, we enhanced CMake support. So you can directly import CMake files into the IDE. So bringing your development workflow with CI/CD processes to the desktop, or even moving it up to the CI pipeline. So how does that work? If I move here to project and select here to create a new project, there is a new option here that it's CMake for ARM. And as you can see, there are a few templates here. We also support the C solution IAML file, but now I will focus on the CMake list file. So that's the first step. So from here, I have a ready project that I'm going to use. And I only need to click on it to be able to use it. So as you'll see, it will start to load. Of course, it will ask for a name. And as you will see, it will populate a project here based on the information that's actually in this CMake list file. As you can see, you will get everything that it's in this project listed here. I mean, from my certs to also if there are any libraries used. And this means that you can actually now build your project by using CMake. And the most powerful here is actually that you can use the IAR debugger. So it will load automatically all the symbols and path through the source files. And that also means that if you build your project from the command line or even in different environments, CI pipeline, you can bring it, of course, to your desktop and you'll be able to debug it out of the box. So the only thing you need to do here is, of course, make sure that you select the right device for debugging. And if you are familiar with IAR Embedded Workbench, you, of course, know that. And if I just go down here in the list and I'm using this time the IAR Academy board, that it's populated with an STM32F4. I just need to make sure to select it here. And that's mainly what I need to do here to make sure to use the debugger. And you also, of course, need to select the probe you want to use. I'm using here iJet, but we, of course, support many third-party debug probes, JTAG probes. So the list is pretty extensive here. And from here, since I'm all done here, I can build my project. And of course, it would just ask for a workspace name. And as you will see here, it's actually using the CMake to build the entire project pretty fast here. And it is completed. We will be able to mainly debug the output. So we have an L2R file being generated. And if I just connect to the target here, you will see that I can land at main, load the symbols and everything. So it will be ready to run and use all the advanced debugging capabilities from IAR. I mean, I can just step in here and, of course, make use of all the advanced capabilities from the stack, memory, advanced breakpoints, of course, data breakpoints, and so on. So all it's available. As you can see, really straightforward and easy to use. And very important, if you want to add a file or even remove any file here from the hierarchy, you need to add it the CMake list file, because everything that it's in this project will be depending on this CMake list file. Great, so let's move on to the next capabilities. And as mentioned before, we added quite a lot of new devices, but also a new core. I can just mainly show you that we have it in the list right now here. So we have the Cortex-M52 now available here, so you can generate code for this new M core. And as I always mentioned, we have been here before, but the device support from our side is really broad, so we can make sure that we support any device that is out there in the market. Great, so moving on. Let me also dig into the details here. I want to show you some simple examples here that can be useful to show CStat. And we added MISRA C 2023 now. So MISRA C 2023 has been added. It's mostly because, of course, the languages have updated. So MISRA C also had this natural evolution. And if you are familiar here, or if you want to know how to use it, it's really straightforward. If you go to the project options, static analysis, under the checks, you will now see that we support MISRA C 2023. And as mentioned before, or what you should know is that, of course, 2023, it's an evolution from MISRA C 2012. So the standards are, of course, then upgraded, and the rules have been added here with the amendments that have been added to the full list. And what I can do here, it's really straightforward to use it. And if I just run it over one file, or maybe multiple files, you will see that we get a list what we have as issues being triggered that are not compliant with the standard. As you can see, it's starting to list all the issues here. And the best is always, of course, you can just go into, and if you double click here, press F1, it will, of course, take you directly to that message that has been triggered. And very useful and giving you extra guidance is that depending on what you are triggering here in your code, it will always give you some examples. So, of course, you'll have some examples or guidance and how to fix that issue that has been triggered, or that is not aligned to the programming standards. And you can also generate full reports here, and that's, of course, very handy. So you can run this on your desktop, but you can also run this, of course, in your CI pipeline with the IAR Build Tools. And from here, you will see that what are the top 10 messages, top 10 files that trigger most issues, and of course, all the checks and what happened here. So this is very useful, and it generates you a special additional report that you can use. And as mentioned before, with IAR Embedded Workbench for ARM and IAR Build Tools for ARM version 960, you can inspect the static analysis results from CStat and any other diagnostic messages from SARIF viewers or SARIF explorers. I mean, there are different ways to do this, whatever you're using, CI pipelines with automated workflows, or if you are using, for example, VS Code, there are some extensions. But if I just open quickly here, you can get a feeling how that looks like. You can use CStat from VS Code, and from there you get all the information on the SARIF Explorer. Good. Moving on here, I can also show you a bit more, because we talked about the special features about generating shared objects, and the linker can do that now. And this functionality lets you then create shared object libraries. And that's, as mentioned before, similar to Linux objects. That gives you more flexibility during runtime for loading and to do a modular application design. So how does that work? We provide in the IDE a ready-made example So I will load that example. It's under source shared objects in the installation of your IAR Embedded Workbench. And mainly what happens here, we have the code that is shared here, and that should become a library. And we have an application that will mainly load it. So we need to build buff, of course, once you load them. So I will build the application. The order of building it doesn't matter here, actually. Or you run into a debug session here. So I can show you what happens here in the shared C code. We have this function named ×2 and also double sum, and some messages being printed here. And in the application, we have then our main that will, of course, then load this shared object. And from there, we'll, of course, continue running the application. I set some breakpoints here. So to give you a feeling how this works, of course, if you want to dig in a bit more into the details, you can look into the linker file, where exactly we are allocating the memory and placing everything. So you can, of course, look on the details here. The same, of course, it's valid here on the application side, where we have the generic memory mapping available, but you can control that, customize it the best way you want. But mainly to give you an idea how this works, if I start a debug session here, I'm using the simulator. I will be able to run here and land on main in the application. And maybe I just need to organize my windows a bit better here, so we can understand what I want to show here. Maybe the disassembly is not so important right now, but the messages are important. So if you look what's going on here, as I said, from main, we will call the DL open. So we are loading this shared library. So I'll just run this application, and then we will enter here. And I just want to show you in the call stack what's happening here. So of course, it's already printing here the information. So it's sending the message hello from the imported printf. That's part of the shared library. And if I continue here the step by step, we will get back here on main. Of course, if I just leave it running for a bit more here, we land here on print here from actually the application. So if I just continue here, as you can see, it passed here. I put some tests here, but at the end you can see that we successfully loaded this library. Usually it's expected that your RTOS should also support this, so it makes it easier to use and of course more sense when working with modular application design. Great. So I would like to thank you for your attention. If you want to learn more or get the latest version, just check it at iar.com/eval, and you can download our latest version too. Thank you.